So good morning or good day sa inyo. We as a bit of recap of what we had sa topic sa temperature, heat and maybe calorimetry. We understand that when heat is introduced to something, it may cause changes to that object physically. Magsilingit ang physical changes, wala sang chemical reaction nga na-involved. So the material, if it is copper, kagin init, tas siya gitagaan, tas isang init or an added heat, the material still remains to be copper. Wala siya naglain into a different compound, into a different element or substance. It is still the same, but maybe something changes in the material in the way it ang iyang length, maybe ang iyang area, iyang volume naglain na. So one of the effect that we know, a physical change that the material will undergo is thermal expansion. Nagalain ang iya dimension. Another area where we also see a change in the material or in the substance is when it changes its phase or its state. From solid, it changes to liquid, liquids into gases. So these are also effects of heat. But this change in the phase, from solid, liquid, gas, or from gas back to liquid, back to solid, these are all physical changes as well. So if we are talking about frozen water, which is ice, ice is still water except that it has become solid. So what was introduced or what was removed, maybe the presence of heat. So when we make it from liquid to solid, then heat must have been removed from the material. So again, there are physical effects. There are physical effects of heat. So again, we start out again with this thermal expansion, and when heat is added, we know that materials do lengthen, they elongate. Ang ginatawag natin nga linear expansion natin tawag sini. Now we understand that this will only occur in solid materials. And solid materials, since they behave like a spring, that when you add heat, these spring connections that they have, or bonds, they will now become stretched. So they will move away from one another. But since they are solid, then they will return back to their original dimension. Manubo na naman siya or magamay kung madula na to ang heat. When heat is given off, then mabalik siya sa iya normal shape. But once heat is present, then these spring-like connections nagalayuanay sila. So medyo madako, madako ang iya length, malaba iya length, madako iya area, madako ang iya volume. So so this is for solid materials. Now we were able to have these equations. Last time that if we increase the length of a material, then it has something to do with its original length. Kung kita nga delta L dira nga madugang, inang delta L or change in length happens to be directly related to the increase or decrease in the temperature. So that increase is what we call as change in temperature. And we can get that by subtracting two temperature values. So eventually, ang aton nga change in length or delta L is related to the original length and also to the change in the length. Now, mayroon kita na quantity nga idugang which we call as a coefficient of a coefficient value. Ang ini nga coefficient value is used to make the proportionality that we have earlier to be equal to one another. Ang inang coefficient of linear expansion changes from one material to another. So for iron, ini ko alpha value, ang ining alpha value sa iron. we get to know this not to be equivalent to a value equals to this one. No? So that's a very small value. So pwede naman na siya ibuon nga, you can write that no in scientific notation like 11 times 10 to negative 6. No? So you can write this in scientific notation. No? So but in decimal form, then we have 4 zeros. No? 0.000011. No? So there are 4 zeros before the digits 1 and 1 or 11. No? And this is per no, degree Celsius or per the change in the temperature. No? So amo ni ko nung kalabaon sa aton nga sang iron no nga iya nga i-elongate for every 1 degree Celsius of increase in temperature. No? So pwede mo na siya intindihan as 0.000011 meters. No? Ang iya i-elongate kung may ara ka 1 meter of the material. No? Kung pasakaon mong temperature yan no, by 1 degree Celsius higher, no? Like from 39 degrees Celsius, you make it 40 degrees Celsius. No? So that's how we understand the coefficient of friction. This is how much increase in length no, will happen for every 1 degree of temperature nga pasakaon mo. No? So kung dublihon mo na ang iya saka sa iya temperature, then madubli man ni ang iya nga pagdako sa iya length. No? So this is that's the constant for every 1 meter of the length of the material and for every degree Celsius no increase. No? This is how much number of meters also ang iya nga i-elongate. No? Okay, so in this case, ang aton nga ginobra dire, no? We increase the temperature by 26 degrees git. No? So ang ining 0.000011 i-multiply mo na by 26. No? Amo na ang madugang gid sa iya length. No? Given nga may ara ka 5 meters man sa material. No? So ang inang 5 meters for every 1 meter sina, no? Amo na niya nga i-increase. So kung i-multiply mo na 5 times, no? And then multiply also by 26, the total length no, nga iya nga dakpon karon no? Will now be no 00143. No? Amo ning gin-elongate yan. No? So the elongation is added to the original length. So we now have the final length. No? Okay, now moving on. So that's how we get no, the change in length. And the final length is simply the change in length plus the no, original length. No? So amo tani magkuha sang iyang final length. LF there is our final length value. No? And of course, no, ang ginduga nga length plus ang original length, amo na ang aton final length. No? Now, in terms ng aton naman yung area, no? Area expansion. So the materials will not only expand no? Linearly, no? Ang iyang length, hindi lang daamo na ang madugang. No? But now we know nga madako ng iya area man. No? So it will expand in all direction. So however, no, may ara kita digin dugang nga value which we call as beta. No? So the beta value, no, or we call it as the coefficient of area expansion, no, happens to be twice of alpha. No? So if you have a metal, pero ang metal ginimo mo na siya nga flat or may area na siya, no? So ang iyang beta value is twice ang imo alpha, no, or ang imo coefficient of linear expansion. No? Ang wala lang relationship sang beta, no, ining do letter B, no, with alpha. No? So that's twice of alpha, no, ang beta value. So if it is iron again, no? So ang atong value naton kay nga 0.0011, no? I-times 2 mo lang to, no? That's how you get your beta value. No? And our value, no, for the final area of the substance is original area plus ang iya change in area. No? Ining beta AO delta T, no? That's your change in area. No? So para tani kwaon ang ining original area yan. Of course, gamitan mo sang formula, no? So if it's a square, then length times length lang na. No? So ang inang iyang original dimension, no, allows you to no, get the area of the substance. No? So if the material is circular, gamitan mong formula sang area sang circle. No? So maybe area sang circle is pi r square. No? So, ang maning imo original area karon. No? So, the original area plus the change in the area will now become your final area. No? But beta here maski hindi na pag-ihatag sa imo, no, you can get it, no, by multiplying twice, no, ang aton alpha value, no. So from here, no, we see that we can get our beta value by multiplying it by twice alpha, no? And similarly, now we can get the same result, no, by using, no, the formula, no, this two set of formula to find either, no, the change in the area only or the final area, no? But anyway, now here is our added example here, no, sa aton nga area value. Now, ang aton nga next nga example there is volume, no? So, ang reason why taas ang aton nga temperature sa aton thermometer, no? So if you have an alcohol thermometer, nga nagasaka na ang iya nga liquid sa sulod because ang volume sang alcohol sa sulod, no, naga-expand, no? So as the volume expands, then its length, no, of the temperature mahatag sa sang correct temperature value, no, because of the liquid that is expanding inside. So the liquid expands faster than the glass, no, nga naga-hold sa iya sa isa ka thermometer, no. So this is the point, no, nga substances will not only lengthen, no, or elongate, pero nagadako iya area, nagadako iya volume, no. So if you have two substances together, no, in one container, if the container expands slower but the liquid expands faster, pwede nga mag-awas ang liquid, no, like when you boil water in a kettle, no, sa isa ka takori in a pot, no. So nga nag-aawas gid ang tubig kay nagbukal, maybe, you know, the water or the liquid inside expands faster, no, than its container, no? Pero kung ang container ni dasig man mag-expand, no, then most likely, no, we will be able to prevent spillage, no, or, no, ang overflowing ang nag-overflow nga liquid sa sulod, no. Okay, now increase in temperature could cause, no, that change in the volume also, no. Now, ang iningaton nga volume, guys, no, may ara kita di coefficient of volume expansion, no. Inang coefficient of volume expansion, no, if we will relate that with our coefficient of volume expansion gamma, no, ini, no. So your gamma value, no, which we denote by this symbol, no, is actually equals to 3 times your alpha, no. So 3 times alpha, kay inaya ang volume coefficient of area expansion is twice of alpha. Iniya 3 times, no. This one now is 3 times your gamma value. So ang daw letter Y nga ina, no, is 3 times your alpha, no. So still, if we are given the iron substance kaina, no, so what if ang aton nga container is made of iron, no? Nagubra kada sa kaldero nga iron siya, no. Kung sa Ilonggo na, I think ang word nga iron is pondido, no. Amo na ang word nila sa iron, no. Inang iron ginausab naton sa kaldero, no, sa mga engine block, no. They are made of iron, no. And the volume expansion of iron will be, no, this one, no. Okay, so our formula eventually for finding our volume expansion, no, is this portion is your change in volume and added to your original volume will now be your final volume, no? So again, no, ang gamma da, no, kung wala ginhatag, if gamma value is not provided, then you can just use 3 times of alpha, no? Okay, now in solving this, no, in this problem, no, we could have this formula here, no. Either you will not consider anymore the change in volume, but use this formula in brackets, no, in sa red, no. Then you can also get, no, your change in or in your final volume, no? So final volume is increase in volume plus the original volume, no? So here, no, if we have to consider copper, ang aton gamma for copper, no, will be 3 times the coefficient of linear expansion of copper, no. And copper is no, 16 times 10 to negative 6, no, ang iyang alpha value. So 3 times that, no, mahimo siya nga 48. No? So 48 times 10 to negative 6, no, would be equivalent to this expression. No? So here's our gamma value. No? So because, no, again, you are dealing there with a copper cube. No? Cube is, to get the volume of a cube, then you will multiply the sides 3 times. No? Side times side times side. No? So manotice nyo nga agin multiply ang tatlo kasi 6 nga ina. No? Because this is the dimension of the sides of the cube. No? So if one side there is 6, erase mo lang siya sa third power actually. No? Or the volume of a cube is s cube. No? Managin multiply nato ani ang tatlo ka 6. No? So the 3 values of 6 that are multiplied together is giving us now 216. No? So substituting that, now we can solve, no, the final volume of the, no, of the cube, no? Once there is now expansion. No? So ginsaka niya temperature, no, from a temperature that is ang iyagali guro change in temperature ang mana ni ang 75, no? That's now the change in the temperature, no? Kaya wala naman siya sang iba nga temperature value, no? So maybe, no, what was considered there is initially it is at 0 degrees, no? And then ginpasaka siya at 75. So the change in the temperature is basically 75 degrees, no? So getting the difference, no, of the final and the original volume, amo naman yung aton nga change in its volume. No? But actually, you can get this value, no, by using the expression nga ini. No? So this one is actually your change in volume. They are now similar in formula. No? So kung amo ni siyang gamiton mo, makuha o manigya po ng 0.7776. No? So if you use this formula over here. No? So again, now that's our value of the change in the volume, the value of our coefficient of volume expansion, gamma, no, which is 3 times alpha, and your final, no, change in final volume. What we know is that one effect again, no, is when heat is introduced, the materials change its length, its area, its volume, no, when it is subjected to an increase, no, of heat, no, or when heat is also removed. No. So again, a copper when heated still remains to be copper. No. It's a physical change only. No. Now another area where we can also see, no, the effects of heat is when it also changes its phase. No, but another way that they also know, no, ang heat, no, is a form of energy, is that and that energy heat is able to be calculated because it flows. No? Now the reason why we can get, no, kung pila gid ang heat nga na-absorb sang body, no, or pila ang yagin give off, no, pila ang heat nga ara sa isa ka pagkaon, no. Why are we able to do our work? No? Because there's a stored form of heat, no, in food. No? So, kung nakakaon kita, then we are able to complete things because it provides us with energy, no, ang pagkaon. No? Now, because of the nature of heat nga naga-flow siya ko, no, that is why, no, that we are able to measure, no, its value. No? And one of the things that allows us to measure heat, no, is the use of the device called a calorimeter. Now, ining calorimeter, of course, no, nagagamit ni siya sang thermometer man, no, to indicate sang iya change in temperature. No? Now, when there's a change in the temperature, we know that heat will now transfer. No? The way heat transfers is that it moves from a body, no, of higher to lower temperature. No? And because of that, no, amo na ang way nga pwede naton ma-measure ang heat. No? Now, there's a method called methods of mixture, no, in our discussion of calorimetry. No? Again, no, ang ini ko nung pag-measure naton sang heat can be taken, no, by using this formula. No? Now, there's a value here called or symbolized by letter C, and letter C is our specific heat. No? And in the previous slide here, now we can describe specific heat as something like the heat that you need, no, para nga magsaka or magpanaog ang temperature ng isa ka substance. No? So kung ang kaldero gusto mo siya initon and you want to raise its temperature, no, by 1 degree Celsius higher, then you must know kung pila ang iya specific heat. No? So once you know that, no, for every gram of that substance, or every mass, no, of that substance, you can know pila ang heat nga gamiton mo para nga magsaka or magpanaog ang temperature yan. No? And again, we call that as the specific heat. No? Now, in determining the amount of heat that a body needs, no, or the heat capacity of the body, then we use that value of the specific heat, no, together with mass, together with the change in temperature to know Q. No? And Q usually is referring to the heat energy, no, that it was able to flow or to get into the substance. No? And in this slide, no, we call it as heat capacity, ang meaning Q. No? Now, Q is given to be mc delta T. And C here is the specific heat, M is the mass, and delta T is the change in temperature, usually final temperature minus initial temperature. Now, ang ina nga knowledge, no, of heat capacity, no, gamiton siya naton diri sa idea sang methods of mixture. No? And ining methods of mixture, samuo na to ng init na substance sa bugnaw nga substance, and we will see that there will now be a change in temperature and eventually heat will eventually travel. No? Masaylo na karon ng heat na to. No? Now, the idea of methods of mixture is built, no, in the idea that when there's a difference in temperature, heat transfers from a hotter body to a colder body. No? Now, however, ining gasaylo nga heat, guys, no, from a hotter to a colder body, is believed to be equal. No? Kung ilang heat that is given off, no, by a hotter body, masaylo lang ni siya sa colder nga body, no? Especially if you put that, no, in a confined container. No? Kung i-insulate mong isang container kag sila lang da ang naga-interact, no? Then ang ina nga transfer karon will be completely, no, from hotter to colder body. No? Now you can only do that if you isolate again, no, your system. No? So kung magsiling ka nga i-isolate, i-insulate mo ang iya palibot, no, para nga sa sulod or sa dira lang sila naga-silo ang aton nga heat. No? Now we can do that again, no, in a device called a calorimeter. No? Now let's read this example and we will understand the concept of methods of mixture here, no? How heat flows, no? And maybe now applying it as well, no, in given situation, and using the equation of our heat capacity, no? Mato ang mc delta T nga symbol natin. No? Now let's read the problem, no? The temperature of a metal specimen weighing, no, 350 grams is raised to 100 degrees Celsius. No? It is then plunged to a 500-gram water. That water is colder, no? It's 20 degrees Celsius, which is now placed inside a copper calorimeter. No? So there's a container that is 100 grams that is made of copper that we call as a calorimeter. No? So your water is inside that bucket or container, no, made of copper. No? So the water and the container, since they belong to one system, they are both 20 degrees Celsius each. No? Now you have a metal, which we do not know what kind of metal, this 350-gram metal. No? Ang iya temperature, 100 degrees Celsius. No? So this 100 degrees Celsius nga metal is mixed, no, or was put together with the colder water nga ara sa container nga copper. No? So kung ginsamo mo na ni karon ng init nga metal, no, maybe a metal ball, sa bugnaw nga tubig, heat transfer, no, will occur. No? So the hotter metal will now give off heat, and the colder water will now gain or will absorb the heat. No? Now, finally, no, when they mix together and after some time, no, nipabayan sila, no, maybe a few seconds after, ang aton nga system, no, pagkuha naton sa temperature, ang 20 degrees nga tubig, nag-init siya gamay. No? Ang init nga metal, nga 100 degrees Celsius, nagbugnaw na siya. Kag finally, no, ang tatlo ka material, ang container, ang tubig, kag ang metal nga init, finally, no, nahimo sila 25 degrees Celsius. No? So this is now the temperature of the mixture, no, after some time. No? So again, no, some substances eventually give off heat. Some substances absorb the heat, no, that was present. No? Now again, no, ang inikuno atong suludlan, ang calorimeter is made of copper. No? So therefore, its specific heat, no, of the copper container, no, a calorimeter, is 0.093 calorie per gram per degree Celsius. No? Now, ano ang ginapangita sa atong problem ini? No? Maybe, no, what we want to find is the specific heat of the metal ball nga gininit kaina. No? Okay, maybe, no, we cannot identify it. No? So once we know maybe its specific heat, then we can look at it, no, on the chart and be able to identify kung ano na siya nga metal. No? Because it was not specified, no, kung ano gid siya nga klase metal. No? Ginamba lang siya nga metal specimen. No? So is it iron? Is it copper? No? What is that metal? No? So we do not know. No? So that's what we want to determine. No? We want to determine the specific heat of the metal specimen. No? So again, now the idea here of finding the specific heat of the metal specimen is to use, no, the methods of mixture. No? So here's our calorimeter, no? This container here. No? Now usually you can insert a thermometer there, no, to monitor the change in the temperature, initial and final temperature. No? And here is your, there's a handle here. No? Maybe you can use this, no, to steer or to do something inside the container. No? And it's insulated. No? So there's a cover for this one. And you will be placing this, no, on a larger container, no, para nga ma-isolate siya. No? So ang heat nga naga-transfer sa sulod, hindi siya affected sa environment. No? So it's an isolated system. No? Now, a calorimeter again is a device that we use, no, to measure the heat that was present. No? Maybe this is the metal ball that we will now mix, no, with the substance and the water. No? Pero ini siya 100 degrees Celsius ning nga metal. No? The container which contains water, no, 20 degrees Celsius na sila, kahit they are also in a system. Now, when you mix them all together, amo na nga nag-25 na sila after a while. No? I hope you can picture out the problem there. No? So again, now which one will give off heat? Obviously, the metal that is hot. No? So when you put that in the cold water, which is 20 degrees Celsius, the water will now gain heat. No? So the water and the container that holds the water, which is the calorimeter, will both gain heat. No? So two of them will gain heat, while the metal that you added, the hot metal that you added, will now give off or will lose heat. Now, again, this equation could probably be think of, no, as our methods of mixture already. No? So some materials will give off heat, some will gain heat. No? Now, which one again will give off heat? Of course, ang aton metal specimen. No? Now, how much is that heat that is given off? It is equals to the heat capacity, which is mc delta T. No? Now, the mass of the metal specimen is 350 grams. The specific heat of the specimen is what we want to find, no? So we don't know it. So we can just simply call it as C sub S. No? Ang iya change in temperature is from 100, no, himuon siya nga 25. No? So may ara siya change in temperature nga 75 degrees. No? Kaya ang iya nga initial temperature 100. No? Tapos nahimo sila finally nga 25. So the change in the temperature of the metal specimen is 75. No? Now for our water, ang aton water is 20 degrees. Nahimo siya nga 25. So nagsaka na di together with the calorimeter. No? So 25 minus 20, will now be equivalent to 5 degrees change, no, in the temperature of the water and the calorimeter, no? Now your calorimeter is made of copper, no? So its specific heat is 0.093, while its mass is around 100 grams, no? So the mass of the calorimeter here, no? Ang atong tubig kay na was 500 grams, I think, no? The specific heat of water is 1 gram, no? 1 calorie per gram, no, per degree Celsius. No? So again, no, we have water, we have a calorimeter, and this is the conditions, no, of our substance. So we have a 350 grams, no, a specimen. So this is the hot metal. So ang change in temperature again is 175, no, while the other two is tag 5 degrees Celsius lang ang ila change. No? So this is the mass and the specific heat of each substance. No? Now, if we will replace this value now, no? So we will substitute the value there. No? So for the mass of the specimen, 350 grams. We want to know its specific heat, so C sub S lang. No? So that's what we will calculate. And the change in its temperature nga 75. So question, no? Positive na siya when our formula for change in temperature is usually final minus initial. No? Kung initially, no, 100 siya, so dapat 25 na final minus 100, no, will give you negative 75. But you look at this value of the change in temperature, nga positive siya. No? Now usually, no, what we will use, no, kung dito siya ibutang ang change in temperature sa specimen sa left side ng equation, we have to keep the value there positive. No? So instead of 25 minus 100, himuon siya positive by subtracting 100, no, minus 25. So this portion of the change in the temperature of the hot material is from initial minus final ang guaya. No? Para nga mag-positive siya. No? So man nga nag-75 na di nga positive value. No? Now the other side, no, so ang water is 500 grams times sa specific heat ng water nga 1 calorie per gram, no, per degree Celsius times 5, no? Whereas your calorimeter is 100 gram calorimeter times the specific heat of calorimeter times its change also nga 5 degrees man, no? Kaya again, nag-5 na bangod kay 25 ang final, ang iya initial is 20 degrees, no? Now, combining the equations on the right side, i-multiply niyang duha ka side, no? That will now give you, no, around 2,546, no? And if you will look at the value, no, so we combine all these values together, that's calorie per gram per degrees Celsius, no? So actually na kung ipang-cancel mo na, no, ang grams na ma-cancel out na sila, no? So ang value niya actually sa right side is only calorie, no? Or no, gram per no, that will be simply calorie, no? Then the left side, no, kung i-multiply mo naman ng 75 sa 350, then you have 26,250 gram, no, per degree Celsius, no, a gram Celsius, no. So therefore, now if we divide both sides by 26,250, then we could have a value there that is less than 1 already, no? And your unit now will be calorie per gram per degree Celsius. No? Now, ang ining value nga 0.097 is very close to 0.93. No? 0.093. No? Which I believe, no, is also very near to copper. No? So, ang atong sulodlan nga calorimeter gali, no? Or ang atong specimen nga metal gali, no? May be most likely, no, made of copper substance as well. No? Looking at the calculated, no, C sub S value, no? So this is how we use the methods of mixture, no, in finding, no, the specific heat of the metal that we heated up, no, earlier, no? So maybe now, but with that specific heat value, you can look at the tables, no, because specific heat may ara na list of tables, no. So if you look at the list of tables of the specific heat of all, no, all metals, then maybe, no, you can compare your answer, no, with the listed value, no. And with the listed value and the value that you calculated, you can probably come up with a name, no, of the metal specimen, no? By virtue of, again, no, kina-calculate mo na ang iya specific heat. No? So the nearest possible value there, no, probably could match the name of the given metal. No?